Hello everyone, welcome to my channel on data analytics. I am your host, Professor Raghav Uday Kiran. In this video, we talk about how to implement a pattern mining algorithm that is available in FAMI library. The outline of this talk is as follows. In the real world, we have different types of databases and multiple computing environments. Furthermore, each database has its unique database characters. So, in this heterogeneous and complex real world, it is important to know what controls what. So, we will be covering first this topic in this video. Next, we discuss the inputs and outputs of a pattern mining algorithm. Next, we provide the pseudocode to execute a pattern mining algorithm. Finally, we provide a demo explaining the process to implement a pattern mining algorithm. Now, coming to the first point, that is what controls what. So, as you can see, the real world databases are complex. They are of different type and have different character. For example, we can have transactional database as a database type. For this transactional database have different characters. For example, some data transactional data sets may be dense or they can be sparse. When we provide these databases to the pattern mining model, what we do is we implement the model using various algorithms and then discover the interesting patterns. This everything happens under a particular computing environment. For example, it can be a CPU centric environment, GPU centric environment, or a distributed environment. So, this is where the computation actually happens. Now, the key question that comes in mind is what controls what? How the database type, the database character, and the computing environment influence our model selection and the algorithm. So, let us look at this key point. So, we have to know that the database type controls the pattern model. Computing environment controls the algorithm selection. The database character controls the algorithm's performance. So these are the three things we have to keep in mind. Let us discuss each of these points in detail. First, let us see the what controls what, where we are talking about how a database type controls the pattern model. Now, assume we have a transactional database which we are providing it as a input to the frequent pattern model and we are extracting the patterns. Now, if I change the transactional database to a temporal database and input it to the frequent pattern model, then we will not get frequent patterns because the frequent pattern model do not recognize this timestamp information that is available in the temporal database. Let us see how computing environment controls the algorithmic selection. So we have a database that we are inputting to a pattern mining model and we are discovering interesting patterns. For this condition, let us consider this example. We have a transactional database which we are inputting it to the frequent pattern model, and we are extracting the frequent patterns. The computing environment we have chosen here is CPU. Okay. Now, if I change the computing environment from CPU to GPU, then the algorithm changes. We cannot use the same algorithm. This is what we have to understand. For example, okay, if we are using ECLAT algorithm to discover frequent patterns in a CPU centric computation, then for GPU centric environment, we have to use its corresponding variant. For example, CUDA ECLAT to find the patterns. We cannot use the CPU algorithm directly on the GPUs. Now, let us see how the database character controls the algorithmic performance. So, if your dataset is dense dataset, then you can use ECLAT algorithm to discover frequent patterns. Similarly, if your database is sparse, then also you can use ECLAT algorithm to find the frequent patterns. But the thing is, the performance of ECLAT algorithm in sparse and dense databases is not the same. ECLAT algorithm works best when your dataset has dense characteristic feature. If your database is having sparse characteristic feature, then F, FP growth is the better choice. Eclat works, but it should not be your first choice. So this understanding you need to know. Once you understand these three parameters, then it becomes very easy to understand how to use a pattern mining algorithm and how to provide its inputs and outputs. So the overall structure of a PAMI algorithm is as follows. For every algorithm in PAMI library, we have input and we have outputs. Input is generally the data and the algorithmic specific constraints. So these are basically the inputs. Output is going to be the patterns, the runtime taken by the algorithm, and the memory. So we are going to output two types of memories. First one is RSS memory and the another one is USS memory. Now, given this input and output for the pattern mining algorithm, the key question is how does the data look like? So, the data the user can provide in three formats. First, user can provide the data as a file, or he can provide it as a data frame, or if your data is in some location, you can provide the URL of the data also. If you provide the URL, our algorithm downloads the entire data and then executes the pattern mining algorithm on it. So you don't need to have the files locally on your machine. If they are stored remotely, you can also access them. Now, having defined the inputs, especially about data, now what are the outputs? So if we get patterns, then what we can do is we can list all the patterns generated by a pattern mining algorithm. Next, if you want to store those patterns in a file, you can store them. Also, if you want to retrieve the patterns as a data frame. One can also get the generated patterns in a data frame so that these patterns can be later used for other purposes such as visualization and sonification. Now, let us look at the pseudocode of the pattern mining algorithm. As I told you, in PAMI library, the algorithms are hierarchically structured. If you want to know the architecture of the PAMI, please check the link provided above. Now, the pseudocode is very simple. First, you have to say PAMI dot, then you have to define the model, what type of pattern model you want to implement, and then what is the pattern type. Once you decide these three parameters, then please choose the algorithm depending upon your computing environment and the characteristics of your database. Once you have imported the algorithm, you initialize the algorithm by passing the necessary input parameters. Once you initialize the algorithm, you simply execute the algorithm by calling the function start mine. This function will start the mining process and discovers the interesting patterns hidden in a database. These patterns can be saved in a file using the save function. Otherwise, you can also retrieve the generated patterns in a data frame format. Now, let us look at a small demo on how to extract patterns from a PAMI library. Let us use Jupyter Colab to execute the algorithms in PAMI. So we are now opening the Google Colab and then we are creating a new notebook. So now first let us install the recent version of PAMI library. While this is installing, let us visit the URL of my website where I have many datasets. So I have plenty of datasets here. So I am copying this dataset T10 I4 D100K dataset, and then what I am going to do is I am going to download this. So once this file is getting downloaded, you can find the file here. So the file is available. Now let us try to discover patterns from this file. To do it, first we have to do is PAMI dot. Now we have to define the model. The model is dependent on the database type. So since our input is transactional database, okay, what we have to do is we can use frequent pattern model. So let us check this. So we are choosing frequent pattern model, and then we are going to find all patterns that are hidden in the database. So what we are going to do is we are going to choose basic. Okay, we are not going to choose CUDA or distributed ones. Here we are going to choose basic. From basic, what we are going to do is we have to import the algorithms. Since I already know in advance that transactional database is a bit sparse, I choose FP growth. If you do not know the statistics of the database, you have to check its statistics and choose the model. As mark. So now I have imported the model. Now I am going to pass the parameters. So the input parameters are the file, minimum support, and the separator. So I am going to provide the file as an input. Then I have to specify the minimum support. That is, minimum number of times a pattern must have appeared in the database. So let us say for me, the pattern has to appear at least 500 times. Since my data set is already tab separated, I don't need to provide it. So now I am initializing the, my bad, I forgot to give it as a string. Now let us start the mining process. So while the process is happening, this the mining process will run and it will discover all the patterns. Once we have the patterns, we can save the file generated patterns in a file. Say frequent patterns generated at minimum support equivalent to 500.txt. Now we have created the file. If we refresh it here, we should see our file here. We can also print the file and frequent patterns 500.txt. So sometimes many patterns will be getting generated. So it is advisable not to open the file. Try to use head and tail commands to see the generated results. So we have identified the file. So the first item on the right side represents the item set or the frequent pattern. The element that is look on your left side represents the support value. Now, if you want to find more, you can also choose total number of lines you want to find and then you can check. So you can see that there is a one pattern where the items 719 and 157 are appearing frequently in the database. So such kind of patterns we can generate from the data. Thank you very much for listening to our video. If you like our work, please press the like button, share it with your friends, and subscribe to our channel for more updates. If you want to know more details on implementing the algorithms in PAMI, please check the link provided below.